Well, my name is Pablo. I work at the NCI as a high-performance data analyst. And what I basically do is I work with data, geospatial data mainly, and we look into ways of packaging this data, so storing this data on this. So after we can use our supercomputer to use this data and do drilling, which is selecting a small area and extracting information out of this geospatial data, or create extents, create mosaics. So geospatial data is data that is about the Earth. So anything, there's many different things, and one of the things that is characteristic of geospatial data is that it's very heterogeneous. Like we have, depending on the sources, we have data that comes from satellites, from simulations or weather models, from radar, and also like looking at the nature of this data, how the data is presented. We have many different projections. So we have, here's some examples, but also another source of heterogeneity is the resolution. So some of the sensors collect very detailed data, others are very coarse. And also another one is the file format. So we have file formats that they are the multidimensional grid with data like NetCDF, HDF, and we have others like geotiffs with rasters. So this is the environment where we are trying to come up with solutions to store this data. So I'm going to focus on satellite data, and also with a specific file format, which is NetCDF, with a use case that we're using. So just with satellite data, we have also many different satellites collecting information in many different ways. We have the high-resolution ones, like Landsat or Sentinel, that because they have high resolution, they get very patches of the Earth, so they take photographs, and they are stored like this, like what is called scenes. There's all the satellites that they produce the data in swaths, so it's the north to south. For polar orbiting satellites, they collect the data with these swaths. Or there's other ones like not as high resolution in geospatial high resolution, but it's called full frame, and an example is Himawari. So for the case of the scenes, we can represent one of these photographs if we just place one of these photographs in the space, and we also, like the satellite collects many photographs through time. So with this time axis, we can represent one of the particular photographs that the satellite takes by this maroon tile, and after for another time we have another tile. And if we throw a bounding box around all these scenes, all these photographs that the satellite has collected, we can just represent this cube with all this information. And that cube contains just an aggregation over an area, over the time that satellite has collected. And if we look from the top of this, we can see that if we want to compose an area that contains, so a big area that is bigger than any particular photograph that the satellite takes, it's just a collection of patches. So this is normally what you see when you see an image that is composed of several images over a big area. Is just a collection of patches of parts of the image. And what is nice of this way of representing is that it fits very well what NetCDF is. NetCDF is a data container, a gridded data container, which can map more or less into this way of organizing the data. So if we turn that and we regularize and we put everything into this format, what we have is cube, a regular cube that contains the information within it. The only problem is that we're taking these patches of information and we are regularizing into this container, and what we have is that we're storing a lot of empty data. And this is not very efficient because the access to the data is slower, and also it takes more space on disk. So to solve that, what we use is two techniques that come with the NetCDF format, which are chunking and compression. And what we do is we do smaller chunks inside this big container that after each individual one can be compressed, and if it happens that there's no data in one of those, it will compress very well. So we are doing two things with this. One is we're reducing the size of the data, and also we are allowing parallelization of our supercomputer to just break the task into a smaller task to accelerate the production of these bigger areas or time periods. So also at the NCI we care a lot about these things, how we can park the data so after we can use our computer to get the best results. So we have come up with this geospatial optimization suite, which is a collection of benchmarks of tests that we do to the data. We try different configurations, and for different use cases after we select or we detect where the best performance is. And yeah, and this is briefly my thought. I think now my colleagues will continue with other things that we do at the NCI.